Welcome back to List of. In the popular imagination, science is a pristine endeavor, white coats, precise measurements, and equations that hum with mathematical elegance. But the truth is, the history of scientific inquiry is often closer to a bizarre collection of late-night ideas sketched onto napkins, fueled by too much coffee and a fundamental misunderstanding of acceptable workplace conduct. Sometimes, to prove a serious point about the cosmos, you must first tickle a rat, build a ridiculous coffee machine, or worry about the legal status of an electron. This is the list of scientific experiments that sound too crazy to be true. Let's start with a title so absurd. It sounds like a civil court case involving Disney and the Postal Service, the Stanford Duck-Stamp Disaster. If you knew nothing else, you'd assume this was a scandal involving forged wildlife permits. But the duck stamp in question was actually a tiny, highly specialized piece of metal foil, roughly the size of a postage stamp, used by the Stanford Linear Accelerator Center (SLAC) in the 1970s. SLAC was analyzing the fundamental nature of electrons, but their experimental hardware kept getting destroyed by the powerful beams. To protect the vital, highly reflective measuring foil, the scientists needed to deflect the excess beam energy. The solution? They literally stuck a U.S. federal duck hunting stamp, the adhesive, collectible kind, onto the surface of the equipment. Why? Because the thin layer of ink and paper created enough resistance and heat absorption to deflect the energy just right, acting as a sacrificial shield and preventing the billion-dollar particle accelerator from melting its instruments. It wasn't a scientific calculation, it was a duct tape solution for high-level physics. And it worked. The disaster wasn't the stamps failing. The disaster was explaining the procurement order to accounting. Next, we move from particle physics to basic human survival. NASA's coffee in space test. Over decades of spaceflight, NASA solved problems that would make Einstein weep: orbital mechanics, long-term radiation shielding, and atmospheric re-entry. But there was one problem that plagued astronauts for years. How do you drink liquid, specifically hot coffee, without violating the laws of zero-gravity fluid dynamics? For a long time, the answer was, you don't. Astronauts drank lukewarm, paste-like sludge squeezed from bags. The experiment was less about the coffee itself and more about capillary action and surface tension in microgravity. In 2015, aboard the International Space Station, NASA finally dedicated time to designing and testing a specialized cup, a wedge-shaped container with extremely sharp corners, that relied entirely on the geometry of the rim to guide the fluid toward the mouth, keeping it magically contained without a lid. It wasn't rocket science, but it absolutely required a rocket to test. The simple pleasure of a hot cup of black coffee required a 5-year development cycle and millions of dollars dedicated to solving the floating liquid problem. Now we address the experiment that never actually happened, but redefined reality itself: Schrödinger's cat origin. In 1935, Austrian physicist Erwin Schrödinger was deeply bothered by the Copenhagen interpretation of quantum mechanics, which suggested that subatomic particles exist in multiple, simultaneous states until observed. To Schrödinger, this was patently ridiculous when applied to the macroscopic world. So he devised a thought experiment to prove that point, creating a scenario so absurd that it had to show how flawed the contemporary theory was. The setup is famously simple. A cat is sealed in a steel box with a radioactive source, a Geiger counter, a hammer, and a vial of poison. If the radioactive source decays in the allotted hour, it triggers the hammer, which smashes the poison vial. According to quantum physics, the atom is simultaneously decayed and undecayed until observed. Therefore, the cat must be simultaneously alive and dead until the box is opened. Schrödinger intended this paradox as a critique, a philosophical joke wrapped in a steel container, never believing anyone would take the existence of the half-dead cat seriously. Yet, his crazy thought experiment became the single most famous metaphor for the fundamental weirdness of quantum reality. If Schrödinger's cat was too philosophical, the next two experiments are purely behavioral and undeniably goofy. First, the great Emu to Human Heartbeat experiment, conducted in the 1990s. Researchers needed to test the practical applications of a specific, sensitive new electroencephalography, or EEG, device. Rather than testing on the usual mammals, they realized the emu, the massive flightless bird, had a unique, low-frequency heartbeat rhythm that was remarkably similar to a human's during deep, non-REM sleep. The experiment was straightforward. Wire up an emu, wire up a human, and see if the EGG could differentiate the sleeping human cardiac rhythm from the resting emu cardiac rhythm. Why? Convenience. Sometimes the strangest analog is the most practical. This brings us directly to a more whimsical biological study, the rat laughter test. Neurobiologists were keen to understand if non-human mammals experienced anything resembling joy or playfulness. They knew that when young rats play, they emit high-frequency ultrasonic chirps. The question was, could these chirps be elicited through social interaction? In 2003, researchers at Bowling Green State University literally spent long hours tickling the bellies and nape of the neck of juvenile rats to see what happened. The result? The rats emitted the ultrasonic chirps reliably and repeatedly, seemingly enjoying the interaction and even following the researcher's hand to demand more tickles. Yes, scientists proved on the record that rats do, in fact, giggle. From tickling rats, we now pivot to the deepest philosophical horror show on this list, the brain in a jar EEG experiments. The trope is famous, a disembodied brain kept alive by science, pondering its existence. In the early 2000s, researchers at the Advanced Telecommunications Research Institute in Japan attempted to make this concept a reality, sort of. They weren't studying consciousness, but rather neural network function. They took living neuronal cultures, thousands of isolated brain cells, and placed them in a nutrient solution, essentially a synthetic jar. They then hooked up the cultures to EEG machines to map electrical activity, the firing pulses of the living tissue. The crazy part? They fed the raw electrical activity into a simulated environment, training the brain cells to control a robot within that simulation. Effectively, they observed isolated living neurons learning, reacting, and operating a virtual body, a bizarre miniature puppet master inside a petri dish. It was a terrifying glimpse into whether the brain, deprived of the body, still harbored an innate drive to process and control. Finally, let's end with an experiment of truly cosmic scale, the dark matter bullet cluster study. It's often said that only about 5% of the universe is composed of the stuff we can actually see. The rest is dark energy and the elusive dark matter. For decades, dark matter was a theoretical placeholder, a gravitational explanation for why galaxies spin faster than they should. The dark matter bullet cluster study was the definitive visual proof. In 2006, astronomers observed the aftermath of two massive galaxy clusters that had collided at incredible speeds. The experiment involved mapping the distribution of mass using gravitational lensing. When the two clusters crashed, the ordinary, visible gas and dust, the stuff that makes up stars and planets, slowed down, heating up and settling in the center. But the dark matter component of both clusters, which doesn't interact electromagnetically, simply sailed right through each other without slowing down, behaving like perfectly invisible ghost galaxies. The experiment didn't rely on a ticking clock or a duck stamp. It relied on two massive galactic structures crashing head-on, giving us a perfect high-speed X-ray photograph of the invisible substance that holds the universe together. Proof that sometimes the only way to solve a problem is to observe the most colossal, chaotic accident imaginable. The history of science is defined by the daring, the logical, and, perhaps most importantly, the ridiculously weird. If you enjoyed diving into the bizarre and brilliant side of research, make sure to like this video and subscribe to the list of channel. We'll be back next time with more facts that are stranger than fiction.